This is section 10-1, Introduction to Sequences. And so today we're going to plot out the first few terms of a sequence. Now just to do a quick recap on functions, we examined so many functions so far. We looked at polynomials and logarithmic and absolute value and exponential and even a little bit of rational functions, and they all had like these special domains that we had to memorize. Specifically, the rational, you couldn't divide by 0. So 1 over x cannot be whatever 0, like whatever makes me divide by 0. And with a log, you can't have a 0 or a negative inside that log, and so we had to exclude that from our domain. So now introducing this sequence, a sequence is a special type of function, and the domain are all natural numbers, meaning your values have to be 1, 2, 3, 4, 5, 6, etc., etc. It can't be 0, and they can't be negative. They can't be decimal either. They have to be whole positive numbers. So let's look at this sequence so far. 1/2, -3/4, 9/8, and -27 over 16. Now each of these numbers, we call it a term. So this is a term, this is a term, this is a term, this is a term. And we actually classify it by first term, second term, third term, fourth term, etc. So this 1/2 would be our first term. This is our second term, third term, and fourth term. And we're going to use this numbering to be able to set up that function. So looking at our function here, the traditional way that we kind of name this is with a. So that's why we're going to have this a sub n here. But now notice, if these are my supposed x values, 1, 2, 3, 4, 5, 6, the ... just means they go on forever. And so the definition of this is going to be a sequence is a function, would be a function a, whose domain is the natural numbers, and the value a sub n is often written as a sub n, so that we can write it as that function. And we say that the nth term of the sequence, that is going to be whatever highest possible term that we're going to go to. So the sequence itself is usually denoted by this notation. So we're going to have some a sub n here. That is referencing either a formula or some sort of notation that could say like the, I guess a better way of thinking of it is, instead of writing out the terms like I did in this previous example here, we could actually take those terms and combine it together into a formula. Now, the figuring out of that formula is going to be a journey. It's not something that we're going to know how to do immediately. We're going to take a look at a couple types of sequences in this class, and then we'll look at a few more in pre-calculus, and we look at a few more even in calculus. And so there's two ways that we can write it. We can write it, and we're going to see the notation this way, and we can see the notation this way. It's just a special way of being able to write it. Now here's an important piece. Instead of just saying my first term is 1/2, we actually use this notation. So that n, I would say being 1, that is my first term. So seeing this, we're saying my first term of the sequence is 1/2. Seeing this, it's saying the second term of my sequence is -3/4. Third term, fourth term. So whatever that subscript is, that's going to tell me what my term is. So let's look at a sequence. So like I said, this is a sequence. Instead of writing out all those individual numbers, we have compacted it into a single formula. So in finding what those first four terms are, what we're looking for is a sub 1. So if my n is 1, that means you plug in 1 into the formula. So 5 to the 1 minus 1 over 3 to the 1. And so 5 to the 0 power over 3. Well, 5 to the 0 power is 1, so you're going to get 1/3. And so to make it a little neater, I'm going to say a sub 1 equals 1/3. Now I need to find the second term. So a sub 2. So that means I'm going to plug in 2 into my formula. So 5 to the 2 minus 1 over 3 to the 2. So that gives me 5 over 9. Because 2 minus 1 is 1, 5 to the first, 3 squared is 9. So I'm going to say a sub 2 equals 5 over 9. Let's find a sub 3. So plug in 3 into our formula. You get 5 to the third minus 1 over 3 to the third. So that's 5 squared over 27. 5 squared is 25. So a sub 3 equals 25 over 27. And then a sub 4, which is my fourth term, that's going to be 5 to the 4 minus 1 over 3 to the 4. So that's going to be 5 to the third over 81. 3 times 3 times 3 times 3 is 81. 5 to the third is 125. So my a sub 4 is going to be 125 over 81. So these right here, these are the first 4 terms of the sequence. So I can write them like that. Sometimes you can just write them as 1/3, 5, 9, 25 over 27, 125 over 81. So there's different ways for us to write them. Writing them in such a fashion that you are essentially communicating first term, second term, third term, fourth term, or I wrote them out like I did up here. Communicating properly, that's going to be the important piece here. And so as a recap, all you have to do is plug in the values for n. All right, so this second example, this is called a recursive sequence, and it's a type of sequence that uses the previous term to construct the next term. And now, how do I know that? Well, it's this terminology right here. It says n minus 1. So f of n would be the current value. So n minus 1 would be the previous value. N plus 1 would be the next value. So that's just notation-wise, but the fact that it says n minus 1, that indicates to me that that's the previous value. As a subscript, that's f of n minus 1, so it's referring to the term of the sequence. Now, the other reason why I included this one, and we're going to see this later on when it comes to example, or the second practice one, is this is the first term that it gives me. Now notice, my n, it isn't 1. Now, it's okay. Naturally, the sequences, we say n is 1, or the natural numbers, but we can actually construct sequences that can basically, we can define them how we want them to. So just be aware of that we can define them how we want to. We can create them how we want to, but naturally speaking, the sequences n is 1, then 2, then 3, then 4, etc., etc. So this is actually technically my first term already. It gave me my first term, so I just need to find 3 more. So that means finding f of 1, that's going to be, well, n is 1 times, and then if I plug in 1, I get f of 1 minus 1. Well, that's going to be 1 times f of 0. Well, f of 0 is right here. So that's going to be 1 times 1, which is 1. Then f of 2. So that's going to be 2 times f of 2 minus 1, which is 2 times f of 1. Well, f of 1 is right there. So that's going to be 2 times 1, which is 2. And then f of 3 is going to be 3 times f of 3 minus 1, which is going to be 3 times f of 2. Well, f of 2 is right there, so that's going to be 3 times 2, which is going to give me 6. So just notice that I used the previous term to construct the next term for this. So my 3 values, f of 0 is 1, f of 1 is 1, f of 2 is 2, and then f of 3 equals 6. Now go ahead and pause it if you guys want to practice this one real quick. Okay, so now going over this one. So I want to plug in where n equals 1. So you get 2 times 1 minus 1. So that gives me 2 minus 1, which equals 1. So my first term is 1. Now, I could also say a sub 1 equals 1. So however I want to write it. Now, it's not written in that, you know, the a sub n equals da 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 da. If I wanted to write it that way, you know, you could rewrite it, a sub n equals da 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 da, to be able to establish it. This is just another way for us to be able to write it. This is just saying all the numbers starting at 1 going all the way to infinity, but they have to be positive whole numbers, right? Well, it starts at positive 1, it's going to infinity. They're all going to be whole numbers. So just however we want to organize it, n equals 2. So that means 2 times 2 minus 1. That's going to give me 3. N equals 3. So 2 times 3 minus 1. That's going to give me 5. And then n equals 4. This could be 2 times 4 minus 1. That's going to give me 7. So a sub 1 equals 1. A sub 2 equals 3. A sub 3 equals 5. And a sub 4 equals 7. So there is my sequence, the first 4 values of them. Next one. Ooh, it says I. Now, are these the same i's that we get with polynomials? The answer is no, because of how I'm defining it. Now, I'm starting it at 2. Okay, so I'm starting this value here at 2, which is okay. Sometimes we can't use 1. There are certain reasons why we wouldn't be able to use it. In this instance, it's just starting it at 2. So again, we just start plugging them in. So where I equals 2, so 1 plus negative 1 squared all over 2. So that's 1 plus, well, negative 1 squared is positive 1. So that's going to give me 2 over 2, which is 1. So the first value I'm going to say is 1. Where I equals 3. So we're going to get 1 plus negative 1 to the third all over 3. So 1 plus, well, negative 1 to the third is negative 1. So 1 minus 1 over 3. Well, that's 0 over 3, which is 0. So I equals 4. So I'm going to get 1 plus negative 1 to the fourth over 4. So then 1, negative 1 to the fourth, 4 negatives, that's positive. So 1 plus 1 over 4. So that's 2 over 4. 2 over 4 is 1/2. And then I equals 5. So I get 1 plus negative 1 to the fifth all over 5. So once again, 1 minus 1 over 5. So that gives me 0. So there's my first 4 terms of the sequence. Now notice I didn't really do a sub 1, a sub 2, a sub 3, etc., etc. I didn't use that notation because since I'm starting at 2, I didn't want to confuse anyone. Just remember that there is a way for us to be able to take this and convert it back into a formula like this. We're not there yet. That's something that we really don't hammer out until calculus, but it is possible. So what did we learn today? We introduced the concept of sequences, how to write out the terms, and how to find the first 4 terms of the sequence. So what is a sequence? Well, a sequence is going to be a pattern, and it's a special function defined where my n is greater than or equal to 0, and they're whole numbers, so we don't want to use any decimals. And it's a function that we define a sub n, and essentially we take those values and we plug them in, and it's going to list out what that pattern is going to be. So remember, a sequence generally establishes a pattern. We can create a pattern. We can find a pattern from it. So just know that eventually we're going to be looking at patterns and how we can take those patterns or get information from those patterns. So this does conclude our lesson. If you have any other questions, please leave them in the comments.